G'day everyone and welcome back to the channel. So, what I want to get done in this video, I had a little think about things. Surprisingly, I haven't actually done any further research because I think basically with this blameless amplifiers input stage, I don't know if it's exactly the blameless input stage. I started with that and then took it all the way. CFP input, 4 transistor mirror, but anyway, the VAS certainly is from the blameless amp, and I have researched every nook and cranny, reached into every corner. I don't know how you want to describe it. I've learned every little aspect about how this circuit behaves, all of its little intricacies, compensation techniques, the behaviors of it, its quirks, its shortcomings, things that you can do with it, band-aids, everything, you know? And the point I'm getting at is I basically sat down, had a really, really good think, like literally just shut my eyes and had a good think about all this stuff that I've taken in just about the VAS stage in the last couple of weeks. And something dawned on me. So let me just explain firstly the reason why I never included a limiting transistor. It's a two-part reason. One, the whole design process with this amp is as least components in the signal path as possible unless the components actually benefit the performance of the amp. I.e., instead of 2 input transistors, 4, it's a benefit. Say maybe having, I don't know, you could certainly add even more transistors and it wouldn't be a benefit. You know what I'm trying to say. That's sort of been part of my design philosophy with this. And so that was one reason I didn't want to put the current limiting transistor in the VAS circuit. The other reason is because it's well known to be prone to oscillation and creates stability issues. And I want this amplifier to be as high speed, high quality as what as what I can get out of the parts that I've got. So, and when I say the parts that I've got, the parts that I have very specifically chosen for this. I'm not trying to make something, for those of you that are just tuning in, I'm not trying to make something out of nothing here. I've actually spent a bit of time researching parts and ordering parts of this. However, this brings me to my theory now. So, knowing my design theory, now I'm going to present my theory on how I'm going to address this situation without putting a Baker clamp diode in there or a current limiting transistor in there. First thing I want to have a look at, current source in the collector of the beta enhanced transistor. Why? Beta enhanced transistor drives the VAS transistor and its collector goes straight to the 0 volt rail. So if I put a current source there, we might be able to address the VAS saturation issue a bit, but it's also going to provide really good rejection from the rail. So it's a win-win. I don't know how good it's going to be in terms of the saturation clipping issue, but can only try. And I mean, it's not going to be hard to do because I've got this 100 ohm resistor here. All I've got to do is just lift one end of that resistor, put a couple of clip leads out here to a breadboard, and I'll just set up another current source. This is a Csink. Yeah, this is a Csink. So I'll leave that off to the side. I've got more breadboard. I don't need all the holes in there anyway. I'll set up a little current source. That's a 2SC3200 transistor, I'll probably use probably the 2SC3206, I think it is. Sorry, 2SA1024. Yeah, 2SA1024. Its partner is the 2SC3206. Yeah, 2SA1024. So I'll use one of those as the current source for that. I might not. I might use something else. I'm going to go have a quick look at my TA92 transistor collection. This device here, it's a TA92F or L, something like that. Large or flat, so I can't remember. It's bigger than your normal TA92 device. I'm going to go have a look, see if I've got something that I'm happy with that's just a normal TA92 device. If I don't, I'll use one of those. So I'll be back in a moment. Oh, sorry. I don't know if I should continue wafting on about this and building this yet, or if I should try and explain my theory behind this a little bit more. I think everyone probably gets where I'm going with this. I just want to see the effect a current source has on this transistor. What I want to see is, you know, does limiting it just end up killing my gain, or does it stop this from going into saturation, or does it do a bit of both? And if so, how much of one and how much of the other? So those are the questions that I'm setting out to answer in this. Just thought I'd put that out there. I'm going to go get some parts. All right, I was tempted to just, you know, use a 2N5551, maybe a KSA 992, or the 1845. I can't think which one's the PNP. Anyway, for that matter, I can't think with the 5401s and 5551s. I'm having a brain blank, but you know what I'm saying. I was thinking about them, and I thought about it, and I thought, no, I'm going to go with the same style of transistor as what's in there, because it's got really good low noise figure and just good characteristics in general. The only thing is I don't want so much gain on the current source. Now, this is lucky for me because I have this transistor, the C3200. I have them in the G, R, and BL category. Two different gain categories. And I have their matching counterpart as well, which is... one sec. Right, so yeah, A1268. So anyhow, I have those, so that's something that I can do. The only thing that I'm worried about, these transistors, I'm not 100% sure are actually genuine. I know that's a funny thing to say because they really do look genuine, just, I don't know. Usually where it's got the letter K and the number next to it, the batch number, it's usually printed. Okay, that one's not. You know what? Maybe these are legit. It's usually printed funny. Maybe I'm thinking of a different manufacturer. See, these ones don't have steel pins, the A1268s that I've got, but the C3200s in the GR category, they are steel. Now, fortunately, the one I need is actually the one that's not steel. Wait a sec. Yeah, no, that's not steel. So let's just measure the gain one of these. I'm pretty sure these were all around 190 to 200, like just shy of 200. Which is why I'm thinking of using it for the current source, because I don't want too much gain in it. But I want to use the same transistor as what I'm using, or its counterpart. Oh. What? It's probably just me that's got this wrong. They're all probably like 290 to 300 or something. Yeah. It was me. I was off by 100. So, hold on. If these are around 300, let me get the other ones. Alright, I got the other ones here that I've got. So, have a quick look. I think these ones have got a gain like 400 or 500 or something, but this is why I'm checking, because I can't remember, and like I said, I want to use the same transistor or its matching counterpart, but with a lower gain. So yeah, these are up in the 500s. Okay, well that's, oops, just dropped one on the floor. All right, well that's that. Well, sorry, I just hit stop. That's that problem solved. I'm going to use these lower gain ones, the A1268s, and we'll build current sources for the beta enhanced transistor. All right, I've just selected 4 of these with a gain of 220. So I mean, they are matched, not that any of that's critical, but like I said before, I'm trying to keep all the components matched between all the channels, so all the channels are identical. I'm going to build this up on this breadboard, so I'm going to build up a little current source using this transistor. And then I'll come back and we'll insert it into the collector leg of the beta enhanced transistor. We'll see what we get. Alright, I've assembled the current source. I used the 2SA1268, but the GR category, not the BL. So let me just pull up the data sheet, make sure that's correct, because that would be another big indication that that was a fake transistor. I think they're legit, it's all good. But I'm just going to double check quickly. So 2SC1, oh god, I've forgotten what it was, 1268. Sorry, it's getting late, I'm getting tired. It happens. Sorry, it's 2SA, not 2SC. What am I thinking? Alright, got the data sheet here. So, oh god, I have to get another data sheet, one moment. Alright, this data sheet's got 2 groups, G and L. I've got GR and BL. Anyway, G is 200 to 400 max. L is 350 to 700. And so this being the R, the GR, this should be the lower gain, and that's what it is. So I'm happy. That's the transistor choice sorted out. Not sticking any crap components in here. Not because I didn't want to just go and stick like a jelly bean everyday, like a BC series part or something that's just really not cheap and nasty. I don't mean it in that way, but this amp's supposed to be high end. So I want to keep everything nice. I'm just waiting for the soldering iron to warm up. I'm going to wire this in circuit. Well, I'm going to give it power first, and I'm going to leave the collector hanging out just so that we can see how much current it's limiting. I've got 3 resistors here. I've got a 680 ohm resistor, a 910 ohm resistor, and the 1 kilo ohm resistor. I don't have any 750 ohm resistors in metal film. I've got them in carbon film and other things. I just haven't grabbed one. This will be enough for now, I think. Alright, so the soldering iron's come up to temperature. So positive is... Actually, you know what? I've just realised this is going to be a bit different because this picks up off of ground. However, let me just wire this in. The thing is, it picks up off ground. So our capacitor, where it's got the two resistors and it goes to ground, that won't go to ground. That's going to go to what, the negative rail? Let me think about this. Yes, so instead of this going to positive and this going to ground, this goes to ground, this goes to negative. I hope that makes sense. I'm sorry if it doesn't. I'm sorry if I've got that wrong and I've made a mistake. We'll find out pretty soon. Where's a good spot for it? I'm just going to put it here. This is only temporary anyway. It's not... Obviously, I wouldn't build the amp like this. Layout is quite important. Alright, that's all I'm going to hook up for now. I'm just going to power the amp up. Let's see if that lights up. Wait, what am I saying? It doesn't have a load on it. Alright. It has a load now. Two milliamps. There we go. So that is with a 910 ohm resistor, we have 2 milliamps. I think that's a good place to start, but I also think I'm going to have to put the other two resistors away. I can't see myself needing more than 2 milliamps here. So I think that's going to be the lowest value resistor that we're going to want. Alright, now that we've established that that's working, I'll go ahead and I'll turn this back off again. Oh my god. Oh my god. Where was that getting dissipated? I just looked at the power supply and there was a whole amp and a bit just getting drawn by the amplifier. I need to see if it starts up stable again. Yeah, it did. That was just a startup problem. All good. I think that was something to do with DC offset build up on here. We'll investigate that later. Obviously, I'm going to make sure that the thing starts up stably. We still got to investigate the gain issue, why it's missing gain as well. I mean, there's a few things to investigate, but one thing at a time. I'm going to lift the end of this 100 ohm resistor. I realise that I won't need the 100 ohm resistor if I put a current source here, but just for now. It's just easy to lift the end of that resistor and just tack the wire from the output of this current source onto the end of that resistor, giving me my current source for the beta enhanced transistor. Just like that. Alright, so now we've got 2 milliamp current source on the beta enhanced transistor. I'm going to take this and I'm going to set it back up on the output. Get this crap off the input. Alright. I'm going to get powered up and see if it will start up. And it started straight up. That's wonderful. Alright. I'm going to fire up the scope and the signal gen and we'll take a look at the clipping characteristics now that we've got a current source on the beta enhanced transistor. I've just realized you guys can't see too much. Let me just move this up. Try and do this without opening up a connection and letting out a puff of smoke. Those things happen. Alright, can you guys see that? Yeah, you can see that. Try and move that up a bit too. Alright. Now I've got to hook this back up. And yes, I saw that spark when I hooked the ground up. That's just, what do you call it, common mode leakage from power supplies. Alright, one sec whilst I get the equipment started up. Alright, I got everything set up. I'm just going to quickly give the amp a little bit of bias because I remember that it's basically got none. Just something, anything. Alright, I'm going to start putting your signal in and have a look at the scope. I'll bring you guys over to have a look in a sec as well, obviously. Alright, I've turned the signal on. Now I'm dialing up the amplitude. Okay. It looks like this has actually had quite a positive effect. Remember in the last video, I experimented with the sub rail, and with the sub rail I could get positive clipping at the same time as that negative clipping, but it was still very ugly on the negative portion. Well, have a look at this. It's still ugly, but I would argue it's a bit neater. You know, that's way neater. Look at that. If we were to compare that little blip there to how big it was before, that is a wonderful improvement. So that idea has actually worked out quite nicely. I'm very impressed with that. Now I'm thinking about the sub rail again, because that would be really good if I could have a sub rail on a current source. All of this stuff will now have rejection from the rails. I mean, really good rejection. But I'm definitely really happy with how this is working. I'm going to play around with some different resistor values and see how different currents affect it. Obviously, you know, it's the standing current is a bit different to what's going on when it's running and it's got a signal going through it, but I still want to see how it affects it. Hope that makes sense. Alright, it's the next day. I've got something interesting happening here, so I'm going to insert a clip right after this so you guys can have a look if you're interested. You might not be. Whatever. I'm all for wildlife. If there's something wrong with wildlife, I will help it. And today I've had an ibis in my backyard that seems to be suffering from heat stroke, so he's resting out there. I've tried to give him some food and water, and I've called wires because after literally half the day he's still out there, so they're going to come and take a look. Anyway, I'll put that clip in here and then we'll continue on with the video. Now it's a little bit hard to show you guys. I've zoomed in a little bit more, and there he is. This ibis has been in my yard all day. I'm currently actually waiting for wires to come out and collect him, because I'm not sure if he's okay or not. I think he's suffering heat stroke. It's ridiculously hot today, but I'm not too sure. Just a quick update. Our ibis friend has moved further into the shade. Seems to be resting now. Rescue is on the way. Alright, so back on this. The ibis is still out there. If anything interesting happens, we'll go take another look. So as we saw last night, adding this current source did improve the clipping characteristics. Currently I've got a 910 ohm resistor in there setting the current, and that equates to about 2 milliamps. So what I'm going to do is I'm going to take that resistor out and I'm going to put 1.2k. So we'll go up a couple of steps, but not too much, just a bit. Because I know with the 2 milliamps, we had even clipping, but we still had a bit of a blip on the bottom portion. So I want to just lower the current a little bit, not too smaller of an amount to actually be able to tell if it's made a difference, but at the same time not too big of an amount to make too much of a difference. I hope that makes sense. That's why I've decided to go from 910 ohm to 1.2k. So let me just get the signal gen powered on. Alright. Let's take a look. Actually, let's do one thing first. I'll just turn that signal off. Let's have a quick look at what the current is. Loop-de-loop. Oh, that's 4 milliamps. What? Hold on. That doesn't seem correct. Oh, that did something to my amplifier and it was taking a lot of current. Not good, not good. I'm just going to take this out of circuit for a sec. How can I do this? I'm just going to form a very makeshift connection so the amp can power up and I can take a look at things at the same time. Right, the amp's powered up and just running without the current source now. Now I'm going to again try and measure that output. Having one of those days today. Stress. Alright, let's see what we've got. Wait, what? Where is that 4 milliamps coming from? Because, hold on. I'm a little bit confused here. I'm sourcing current from the 0 volt rail, passing it out the collector, and then into the collector of an NPN transistor here, which goes to the negative rail. Am I getting... No, that was coming off the collector. Oh, something smells hot. Oh, it must have been from before. Yeah, so... Hold on, I'm having a brain fog. I'm just going to pause and think about this. I'm having a silly moment. Alright, I had to think about that because I want to make sure nothing's not right, so to speak. But no, it can only be current leaking through. When I say leaking, I mean passing. That's meant to be there. You know, from this transistor or this transistor, either way, and it's coming back out the collector. But it's certainly not this. If I load this, it's passing 2 milliamps, so that's fine. So what I'm going to do is I'm going to up, well actually, Have we looked at the signal yet? No. We need to sort this out first. So I've got 1.2k in here. My apologies, I had to stop myself there. I'm supposed to be measuring the current that this is passing now. That's what I was supposed to be doing. I got thrown off by the 4 milliamps and forgot to actually show you guys what it's actually doing with the 1.2k resistor in there. I'll just disconnect this fast transistor for a sec. And we've got 1 milliamp. It's probably more than 1 milliamp. It's probably about 1.5, 1.3, something like that. I'll just leave that there for now. That beta enhanced transistor is back in circuit now. So now let's wind the signal up and see what it looks like. Interesting. You know, even quite a bit before clipping, I still see that pulsating's not the amp. I'm not talking about that. That's just you. Probably just crappy equipment and the sampling of the scope. But anyway, that is not nice. I don't like that. So from memory, sorry if I'm making everyone dizzy holding the phone like that. From memory, it was better with a slightly higher current. Let me just turn this back down, off, turn the power supplies off. What I'll do is I'll put this 910 ohm resistor back in here. That was around about 2 milliamps, maybe more, 2.5, something like that probably. We'll see how that compares. Still the same. It's quite, I was going to say it's a lot more symmetrical, the clipping, than what it was without the current source, that's for certain. But trying to work out the optimum value is going to be a bit of a mission. I might just turn these supplies off. We'll go down to a 680 ohm resistor. I have a feeling the optimum value is either going to be 680, 750 or a K. It feels like we're right on it. Right, that's 680 ohms in there. That is definitely negative before positive by a long shot. Okay, so maybe the 1.2 was I'm going to put the 1K in there. I think the 1.2 was just a little bit too high. I think it's going to be 1K. I almost hate it in electronics, engineering, whatever you want to call it, design, when you're trying to fine tune a circuit and the resistor values all end up being bog standard values like 1 and 10K. I just find it annoying because it's like, someone else takes a look at the circuit, they're just going to think that you just literally threw, you know, jelly bean components in there and just build it with all bog standard values and nothing was fine tuned. Oh, it's just funny. That's what would go through my mind if I saw a board. You know, I'd have to do a lot of thinking about it and work out the designer's choices and why he came to those choices. But anyway, I just think that's funny. the current setting resistor, the perfect value ends up being 1K, that'll crack me up. Let's see what we've got. Now that's still negative before positive, but it is clipping the positive as well. Okay. Quite interesting. We might want to try just above 1.2K. So that was the 1K. I'll just have another look at the 1.2 again. Maybe the 1.2 was the closest, because this isn't obviously the only fix. I want to have a look at the sub-rail and the current source together in this video. I know I haven't mentioned that yet. I kind of alluded to it in the last video. Don't think that just because the rail on its own didn't yield the result I was after that I've abandoned the idea. Some things work in conjunction with other things, you know. Let's take another look at this 1.2K. Still got that negative bit first, but it is quite even at 1.2K. That's funny. Alright, well, just for the sake of it, I'll go up a little bit higher because we haven't done that yet. What have we got here? 1.8K. Alright, 1.8K. Powering up again. Beautiful. Negative starting to get ugly. I honestly do think that that is a little bit more symmetrical. It's trying to clip on the top more than it was. Yeah, that does actually seem to be going in the right direction. Let's just increase it a little bit more. Alright, to save everyone time, I've put a 2.2K resistor in there and I'm just powering it back on. Now, that's another concern. We can't go too high because if this transistor's starved for current, that's going to be a problem. Actually, that's something else I meant to point out too. Something else that I wanted to investigate. Not the emitter resistor for the VAS transistor so much, but the emitter resistor for the beta enhanced transistor. I wanted to have a look at how changing its value affects it. But anyway, let's just continue with what we're looking at right now. I'll turn this back on. No, that doesn't seem to have made any more of a difference. So, from what I can see, around about 1.2K, I don't see any more benefit. I'll put the 1.2K back in there for now. I can't remember what that was. I think it's about 1.5 milliamp, something like that. Which seems pretty reasonable for this. Now what I'm thinking about is how do I want to go about looking at the effect of this emitter resistor? Do I have a look at it with this current source in circuit or go back to it out of circuit? That's what I've got to think about now. So I'll just pause the video for a minute. I'm going to do it with it. Because this is working out, it's most likely going to end up in the circuit. I think it's better we test it with it. So, seeing as I've already increased the resistor value to 2.2K, the first thing I'm obviously going to try, the first logical conclusion is to decrease the value. So for that, I can just series resistors in parallel. I'll start off with a 2.2k resistor, so you know it'll be 1.1k. You guys can't see that too well. Try and make sure you guys have got a view of what I'm doing. I'm just going to go check on that bird because my cat's just made a lot of noise. Alright, just a quick update on the bird before we continue. It's been quite a few hours now that I've had the bird at my place. When I called Wise, they actually asked me to contain the bird. As in like throw a blanket over it and stuff it in a cardboard box. I didn't tell them to get fucked, but that's what I said in my mind. And you can see what I've done. I've gone out into my yard and taken some wooden fencing and a few other things around the place and just put them in locations so that the bird can't just walk out. And as you can see, now he's starting to perk up. He can get out on his own. He can jump up on things and fly away. He's not by any means stuck in yard. I've just made it so that if he can't fly, he can't leave. So I hope that comes across right. If there's nothing wrong with the bird, it can leave. If something's wrong with it, it can't leave, which is what we want, right? So that's why I did that. And as you see, I've put some water out there. I threw some chicken out there earlier, then Googled and found out that they eat seafood, so I put some tuna out there. Threw a bit of banana out there too, just in case. Strangely enough, he pecked at the chicken. I haven't seen him eat any tuna, but he might have. He has drunk shit tons of water. And the other thing I did was I went out there with the garden hose and made a fine mist and just held it up in the air. I've done this about 3 or 4 times today, and the first couple of times he started walking out the yard. This was before I had it fenced off, and I just walked around the other side of him and he just walked back in. I mean, you can tell this bird's not well. I'm a human and I can walk out into that laneway that you saw me walking up in the open and walk in a circle around the bird, and the bird just walks away from me. It doesn't even try and run or fly. And anyway, after a few attempts at trying to feed it and get it cool with water and stuff like that, it eventually came around to it. And the last couple of times it just sat there and took the water. I just enjoyed sitting in the rain that I created, and it started drinking the water that was running down its beak. It started drinking it, and once I saw that, I went and refreshed its water tray a couple more times, and it's, as you saw on video, it's been taking drinks from the tray. It seems the thing that's really picked it up has been water. I think that the extreme heat, like today, was just ridiculous. If you went outside for more than 10 minutes, you'd just want to drop. I'm not exaggerating. Or at least here anyway. So, and it looks like a young bird. So I think what's happened is it's a young bird and it's not tough enough yet. It may not have had enough to eat yesterday. I don't know. But I think it was exhausted, and I've given him a place to rest all day, you know, water, cooled him down a few times. Maybe he's eaten a couple of things I've put out there. And now he's able to, like before he could barely walk. Now he seems to be walking fast and jumping up on top of things and almost doing a little bit of a fly back down and to get up there, I guess, in the first place. So I think he's about ready to leave. So I don't think Wise are going to have to come and get him. I think he just needed somewhere to rest and re-energize. But yeah, I'm going to put a little clip in now so you can see how he's doing. He's doing a lot better. How are we doing, buddy? Hey? You're looking a lot better now. Yeah. Much better. It's okay. Very good. Yeah. Alright. The bird is, that's the second time he's actually made it up onto that ledge now since he started to get better. Both times when I've walked around, I've gone around one time before earlier. Two, I'm not going to deny this. I deliberately did that knowing that he would go back in the yard. I've tried to keep him in my yard as long as possible. Like I said, without like really restraining him. As you can see, he can get up there, and if he really wanted to leave, when I left, he can get back up there and fly off into the open. He's not stuck. I'm just trying to encourage him to stay there in the shade, drink water, make sure he's actually rested before he goes. I just don't want him to fly off a little bit and then just die 2 blocks up the road and end up in another yard that doesn't have a whole load of bush and water and stuff like that. So that's all I'm doing there. Anyway, he is back up on that ledge again for the 3rd time. So I've decided, as it's now the 3rd time he's jumped up there, I'm just going to leave him up there. He's actually still been up there for like 20 minutes. Hasn't left on his own. I'm obviously not out there, I'm in here. So he's literally just where I walked in next to that Honda Prelude that's in my yard. He has got a whole open driveway of space to just fly into open air and a lane behind that. So if he is feeling up to it, he'll take off. If not, he might just keep sitting there or jump back in the yard and go for another drink. But I've done my due diligence and I think he's alright. So I've just got to keep my eye on him now, and if he leaves, I'll let wires know not to come out, and yeah. Anyway, back on with this. I've put the 2.2k resistor in here. So now let me just point something out here. This resistor is going to have a different effect to the effect it would normally have. So let me explain. Normally when the collector of this transistor is attached to the 0 volt rail, either via a 100 ohm resistor or no resistor, it's basically got as much current as it wants to take. Now, it's still only going to use a couple of milliamps with that resistor there and what's going through it in terms of drive, but the point I'm getting at is when you insert a current source into the top, that current source is going to try and make the same amount of current run through that chain no matter what the resistance is. It's just going to ramp the voltage up or down. So changing this resistor value is going to have a slightly different effect to what it would if you changed it without the current source. I just wanted to point that out, just food for thought, you know. I'm not saying it's a problem or anything like that. I'm just saying it's something to consider. If you don't consider how every little thing works and why it's happening, you will miss stuff, and then when things crop up, problems, you won't be able to figure out why you've got them. So honestly, it just pays attention to pay attention to small detail. Sorry. I don't do good at wording sometimes. Alright, I'm going to power this back up. I've got the current source in there. 1.2k resistor. I've got an additional 2.2k over the 2.2k emitter resistor on the VAS. I'm going to power the amp up. Amp's good. I'm going to turn the signal on. That's good. I'll bring you guys over to the scope. Just unlock that. And hey, you know what? I gotta say, that actually, I'm gonna unclip that resistor live. Let's just watch that waveform. So that's without it. With it, without it. With it, without it. You see that blip gets smaller with the resistor. Without, with. Alright, so let's now investigate that. I hope everyone is now starting to understand what I mean about band-aids and doing it the right way. the band-aids to put the Baker clamp on it, the band-aids to put a tracking resistor there, tracking transistor. I'm sure there's other ways if I thought about it or read some more forums or whatever, you know, but like I said, that's not what this design's about. I'm trying to, instead of finding problems and mask the problems so it appears the problem's not there when really it is still there, I want to eliminate the problem in the first place. That's probably the best explanation for my design philosophy that I've probably given you guys so far. Alright, so that was 1.1k. Now, interestingly enough, I don't see how this is going to work, but I remember having 470 ohms as my starting value. And according to my research, the VAS distortion just kept going down to around that 470 ohm region. That was where people were getting really good results. The problem with that is, with the collector of that transistor hooked up straight to the 0 volt rail and a 470 ohm resistor there, when that transistor starts to actually swing, it's going to have a damn lot of current going through it, I would think. But I could be wrong there too, because you got to take into consideration that the input stage's swings dragged down by that, and its swings dragged down by that. So realistically, there's not a lot of swing there. So, well, there's one way to work this out. For starters, we have a current source here. So the good thing about that is we can put those 470 ohm resistors in there that we wanted to have in there. We know that they actually yield good results. We know this already. This is undisputed. I did my research on this. This was covered in earlier videos. When I was breadboarding it, I actually had moved the resistor values down and it made the circuit behave better and better and better. I only moved it up because there was no current limit on this transistor and I didn't want too much current passing, and I calculated for the level of swing and the rails that I've got that 2.2k would be good. So now I've got a current source at the top here that's letting 1.5 milliamps in or whatever. I can go put a 470 ohm resistor there. So I'm going to go get a 470 ohm resistor. I'll go get one of the carbon film ones because I've got, again, a gut feeling, like I was saying earlier when I put something in and I did it permanently, that it's going to be the final value. It was the original value, like I just explained. The reason it got changed is because of no current limiting, but that's there now. So I'll go get that resistor. Alright, I got four 470 ohm carbon film resistors. Due to the small amount of current that's passing through it and the low resistance and the fact that it's not in a really high gain area, like you got really high gain on the input stage, fairly high gain here at the base of this transistor, by the base of the VAS transistor. I'm not saying there isn't gain, but I'm just saying that the gain's not so high that resistor noise is going to get amplified and become a problem, especially at this level. This is what I mean where I say I've really thought about exactly what resistor to choose for where. You know, like for example here, I thought about it and I said, look, a 470 ohm metal filming resistor, due to its lower ohmage and the inductance it's going to have to it at that value, I feel that the carbon film resistor will offer better performance, especially in terms of wave reproduction in this part of the circuit. So I've chosen the carbon film resistor. I'm not trying to tell anyone what to do. You do what you feels right, but I just try to give my insight into why I do the things I do. And I mean, I don't just come up with ideas because they look nice or whatever. I do my reading and my research and have a think about it, and to the best of my ability choose what I think is the best. And I'll just take you guys to the computer in a moment and I'll just show you something. I've got a schematic for an amplifier that I've got here to rebuild. It's one of mine. It's a Yamaha AX700 or AU700, something like that. Beautiful amp. However, if you look at the circuit diagram on it, the whole entire amplifier is built using 6 different types of resistor. There is carbon composition, carbon film, metal composition, wire wound, and like another type that I can't even remember. You know? So before everyone goes, oh, you're nuts doing this. No, back so little as 30 years ago, this is how it was actually done. And, you know, people used to put a lot more effort into making things than what they do now. The cheaper, easier parts, the Csource will do the job, they'll do the job. That's the way it is now. Back in the day, everything was well thought out and it wasn't always about cutting costs. And that's exactly what this is about. I'll tell you what sucks about cleaning up the circuit board. I've been having to add flux to my solder joints because when you clean the circuit board, you remove all the flux. But that's okay, I've got flux and I can clean the board again. Alright, so we've got a 470 ohm resistor in there. We've still got our 1.5-ish milliamp current source. Look, you know what? I was going to say who cares. No, let's not be like that. Let's actually find out what it is, because as you know, I tweaked the resistor to get the best performance with the current source. So now let's have a look and see what that value actually was in an accurate manner. What? Where's... What am I missing here? DC amps, range, definitely want the speed on high. Where the hell is... I don't want 5 amps, I want milliamps. What? I don't know what on earth is going on there. Alright. Maybe it just auto adjusts. I swear there was a way of setting it somehow. So we have whatever you see there on that screen, that's what the current source is making. Oh wow, really? 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 I find that a bit concerning. 500 milliamps. Just out of curiosity, I'm just going to open this circuit up, because if you take the resistor out, some of you probably know what happens. I'm just going to put a 1K back in there. It's only the next value down. That is a 1.2K that was in there. Just because I remember around 1 to 1.2K was really good, but I don't like that. That low? I don't know. Alright, resistors in there. 1K has not made a difference. Hold on, let me hold this 1.2K resistor in parallel with this. Oh, that current source isn't working. You have to be shitting me. You've got to be kidding me. Wait, so how's this been working? What? I feel like I'm losing my mind right now. Let me just go over the wiring of this current source. I'll just pause the video. Because it was definitely... No, I'm not losing my mind. What am I saying? We've retested this. This definitely works. Hold on. This is odd. I swear that was 1.5 milliamps. No. Something's gone wrong. I'm just really confused right now. That is flowing through a resistor, not the current source. I just took the ground reference out so that the LED went out. There's no reference voltage. And I still got the same current. Let me just pop this guy out. Pop another one in. What? It's not the transistor. This was working. This was definitely working. I am losing my mind. What on earth? Base. Emitter. Resistor to the rail. LED to the rail. Other end of LED to the base. And then the resistive divider to ground with the capacitor to the rail in between. What? Is something going on with this meter? I'm putting the 10 amp jack. I got a funny feeling I know what's going on. The meter's resistance is too high. Hold on. What? Oh my goodness. Oh! Wait. Am I supposed to be going to the ground rail? No, of course I've got to go to the negative rail. This is between ground and negative. Something is seriously screwed up here, guys. I'm sorry. Let me pause the video and work out what's going on here, because this was working. I am perplexed. I'll be back. Alright, I've just made an interesting discovery. Check this out. 1 milliamp with my multimeter with a like RO50 current shunt. 2 milliamps. I haven't changed anything, as you can see. It's all exactly the same. I've not changed a thing but the meter. You know what I think's happened? Either this thing's got auto ranging relays on the 10 amp jack as well that can go to higher resistance shunts, or there's a blown open resistor in here. Because why the heck can this not read current? I've got it in series even. I've tried everything. What gives? Like, seriously, what gives? That's the 10 amp jack. Right? And as you saw, if I put the resistor on there, the current doesn't go up. We'll have to look into this in another video. I don't have time now. I could go put 1.2k across that. Probably have about 3 or 4 milliamps. Alright, let's just actually go a little bit lower. I just want to make sure this is actually working. 680. Oh. You know what? Oh, I'm in series with my amplifier. So 1 milliamp, put the 680 on it. 3 milliamps. So, I mean, that seems to be working to me. That's exactly the values I would expect. So, sorry if I sound a bit slow, I just had to think about that just to make sure it was actually right. So that's working. There ain't nothing wrong with that. So, I will put that back in. I'd say it's 1.2 milliamps, maybe 1.5 milliamps. I'd say it's a bit more than 1 milliamp, but I could be wrong. Why am I using my meter? Alright, so we've got the 470 ohm resistor in there. We've got the current source hooked up. Everything is actually working. So let's go take a look at the waveform, shall we, and see what differences we get with that 470 ohm resistor. Don't ask me why I just felt that transistor. I know it's got a current source on it now. I'm just used to it not having one, so if I lower that resistor without one, it would get very hot. Oh, look at that. Come on, guys. Look at that. Hey? Hey? What did I tell you guys? See, now it's a bit on the positive before the negative, but we can... It's pretty symmetrical. We can fix that. That's easy. So, this current source, I'm pretty sure if I put a 1K resistor in there, let's just try and adjust this now. A little bit more current. So this will be about 1.5 milliamps, I'd say, or at least 1.2, 1.3, somewhere in that ballpark. Right now we should be basically symmetrical, if I'm right. Look at that. Symmetrical clipping. I am so happy. So I think that's a very good point proven. I think I've probably covered a lot in this video again. I tend to do that. I'm a very, you guys will get to know me. I'm a thorough person. Anyways, well, with that on board, I'm happy with the 470, and that's not going to get hot because it's got a current source on it. I will remove that 100 ohm resistor. No need for that to be there. The current source will just directly power it. I'll have to design a little standoff board that will go 4 of them in here. What else can I say? I still want to do something about this rail. I reckon now that we have this working how I wanted to get it to work, I think now that we've got this all dialed in, I think we should have a look at running the rail off of around about a 3-volt sub rail again and see how, because that looked almost perfect, but you did see on the negative portion there was still something there. You know, just like a trace of it, but it was actually there still. I'd say we run it off a sub rail and see what that gives us. And then I'll end the video. Alright, my apologies. Excuse me. My apologies if my head's a bit absent today. I've got an ibis in my backyard. I genuinely do care for animals, and I have to keep going out and checking on him. Been waiting for these people to rock up all day. My head's just not in the right space. I keep forgetting what I'm up to. It's not good. Anyway, I can tell you one thing. The amp's been running like this for like half an hour. I forgot to turn everything off, so that's great. Excuse me. Subrail, like I said, now that we've got the current source set and the resistor value set, I'm happy with the input stage, current mirror at the bottom, source at the top, the top half of the VAS, current source going into the driver, the lower driver going into the VAS transistor. It's sort of current limited through the top one way, and now its drive is limited going in the other way. I don't know if that makes sense. I feel if we make, like I said, a regulated rail, sub-rail, we could get some great benefits there, but who knows? I could be wrong. And if I'm wrong, I might end up building a couple of current sinks that go there. Now, I'm going to have to do some research into this, because if I would put a current sink here and here, the reason I'd be doing it is not so much for accuracy of DC characteristics, AC swing, stuff like that, but it would actually be to get rejection from the rail. And that transistor, because it needs to be able to turn on hard, almost saturate, you know, it needs to pull a lot more current one way than it does the other way. So the current source can't be set at, like, I don't think so. I mean, we'll test all this out and see if I'm wrong. But my thinking is that the current source for that VAS transistor couldn't be set at the 4.5, 5.5, whatever it is, milliamps it's set at now. I think it's like 3.5 for the input stage, 4.5 for the VAS. Could be wrong. So yeah, I've got a little bit of working out to do, because my thinking is if I set the current source so high that it's like, you know, 100 milliamps or something like that, is it going to even provide any rejection from the rail as opposed to like an RC filter? Because that was the other suggestions that I've seen to get rejection from the rail for the VAS transistor. I'm not sure about the beta enhanced transistors emitter resistor, but certainly for the VAS emitter resistor, people have not only got the RC that I've got on this negative rail, but they've then got another RC R, so they've divided the emitter resistor into two resistors, put a capacitor in the middle going to ground, and then you get what I'm saying, or maybe going to negative, I'm not sure. I have to think about that. But yeah, so there's a few options, but like I said, sub-rail first. It's the easy thing to do. I want to end this video because I've covered a lot in it, and I'm trying to be conscious of my videos, because every time I cover, I do a lot of work and the video ends up being 2 hours, and I feel bad that I've made the video too long. So let's just quickly lift. Well, let's turn this off first. Turn my signal off. You know what, I just want to show you guys something. I'm just powering my amp back on. Have a look at this. The shutdown's beautiful. One sec. That's great. I mean, everything is well balanced and symmetrically built and matched and all that sort of thing, so should be. It's got decent bulk filtering on all the rails. Anyway, let's lift this resistor. Alright. I'm just going to pause the video and get the sub-rail set up, but I'm also going to set this up so that we can look at DC offset, just so that if something goes sour on startup, I can turn it off straight away. Although with all the current limiting on everything, probably nothing's able to go up in smoke now anyway, but the VAS transistor still could. Probably not so much the transistor itself, because it's just going to turn hard on, but it's going to smoke the emitter resistor. So yeah, 1 sec. Alright, I got that set up again. I'm going to power the amp on. I've only got 10 millivolts on the sub rail, so I can start the amp up. And then, oh, my signal generator's still on. It's got DC offset on it. And noise. You'd be surprised if I unplug this crap. What? We'll worry about all this later. None of this is probably a problem. I'm running off 3 supplies and 2 of them are cheap ass. So I've got crap everywhere. Just, yeah, don't worry about anything too much right now. Alright, so I'm going to turn this up to 3 volts. Alright. Oh shit, that's 30 volts. Fuck. Holy. Listen, I'm sorry for my language, guys, but I literally just jacked that rail up an additional 30 volts. I'm lucky I'm using fairly high voltage parts with headroom. Let me try setting the 3 volt bit, not the 10s column. I'll set the 1s column. Now we've got a 3 volt sub rail. Alright. I'm going to do the same thing again. I'm going to pass the signal through it. But now we have our current source on the beta enhanced transistor. We've got the 470 ohm emitter resistor. And this entire negative rail is run 3 volts below. Let's go take a look. Signal on. Oh wow, that really clips the positive way earlier, but look at the negative half. That yucky bit's basically completely gone. I had a feeling the 2 would work in conjunction really well. That is beautiful. I think what I need to do now is just fine tune this to get this to clip symmetrically. Let's go for it, and then we'll finish this video here. Alright, there's something I want to bring everyone's attention to. Because now we have 3 variables here. We've got an adjustable current source, an emitter resistor, an adjustable rail voltage. Now, in conjunction with the emitter resistor, we've dialed the current source in. But then when we've added the rail, we've got asymmetrical clipping again, but it's also cleaned up the bottom half of the clipping like I wanted it to. So, let's turn the signal on, turn it up to Eclipse, and let's, what on earth, that is, no, that's still the positive bit first. I'm going to now adjust this 3 volts up and down. Doesn't seem to have an effect there. Let's turn this up a little bit more. So it's clipping on the bottom half too. Wait, what? I did this before and it had an effect. Ah yes, look, 0 volts, 1, 2, 3. It's not much of a if you just focus on this bottom part right there, as I go down 0 volts, wait, now I can't see it at all. Oh, I'm not setting anything. Hold on. 0 volts. 1, 2, 3. Oh, damn it. That's 300 millivolts. I'm in the wrong column still. Alright. 1, 2, 3. You see that line drops down and it cleans up that. When it's got no offset, you start seeing that little edge of that blip there. And when I add the 3 volts, it's just flat. So 3 volts is the voltage we're going with. And if I go 4 volts, 5 volts, 6 volts, as you see, there's no difference there. So, oh, hold on, I'm not changing it. 3, 4, 5, 6, no difference. So I'll go 3 point, I think 3 is adequate. Let me go down to the hundreds of millivolts, and I'll start winding it down. Gets ugly about there, gets better. Right on 3 volts, going over 3 volts, up to 3.5 volts. Not really much of a difference. I think we'll do 3.5 volts. It's always good to have a little bit of headroom when you design something, so that, you know, if there's a bit of voltage dip or whatever, you don't want anything to be right on the edge of stability, right? We'll do that. So, oh shit, I've got 6.5 volts. 3.5 volts. Right, okay, now we're set up. Alright, so 3.5 volts. Let me just zoom back out on my scope and I'm just going to put my thing back in the middle. Oh, come on. Stop, you bastard. Hold on a sec. I don't know why I didn't just use the cursor. Anyway, I'm back to looking at it clipping on the positive and negative half, and you know, the positive half's clipping earlier than the negative half now, so we want to do something about that. Now, 3 volts is going to be the rail voltage for the reason I've just shown. So that means the other 2 variables that we have here to get the clipping symmetrical is setting the current source and the emitter resistor on the VAS transistor. Now, I just want to point out the reason I have not been concerned about gain this whole time is I'm putting 3.3 volts in at the moment, and I've got the same roughly voltage coming out, so what I've been doing hasn't affected the gain too much, so that's why I haven't concerned myself over that. We'll look into that after. I think it's something to do with the gain on the input stage, to be quite honest, or the current flowing through it, but we'll work that out when we get there. So I've got a 1K resistor in there. I'll go get those 2 resistor boxes again and we'll start experimenting with different values. So I'm going to go down slightly to 910 ohms again. Alright, we'll start it up and see if it starts up stable. Oh, I didn't realise there was a signal going through. I thought that was DC. All good. Okay, let's go see what the clipping looks like. You know, if anything, I'd say, just turn these power supplies off. Turn the signal gen back down just away from clipping. I'm going to we'll go a bit low. We'll put 680 ohms in there. Starting up again. Oh no, something's not right there. Oh, no, terrible oscillation, Oh, that was not good. So, I had a feeling that was going to be a problem, and I'll tell you why. Because I've got that 470 ohm resistor in there, so as I increase the current here, it's really going to pump current through that transistor. So, alright, let's go the other way. I'll put a 1.8k in there. I mean, this is how science works. We experiment. Put a 1.8k resistor in there. Powering back up. Stable now. Bringing you guys over to look at the clipping. Hey, is that? No. It still just clips on the positive half first. But it is clipping very cleanly. I'm very impressed with that. So, let me just turn this back up towards clipping. Oh yeah, we've still got the same gain with no clipping. So, let's turn power supplies off. Turn the signal off. That's a 1.8k. I had a 1k in there. Here's the thing. So going too low, it started oscillating. I'm not quite sure what that was about. Maybe I put too much current through this transistor and its gain dropped off so much that it was having trouble driving the next transistor. Because it was a lower frequency oscillation. So I think that's what happened there. Okay, well, maybe let's put the 1k resistor back in. Let's work out what the 1k resistor is. That's the one. Put the 1k resistor back in, and we'll alter the value of the emitter resistor on the beta enhanced transistor, because that's the other variable that I've added today. Let's put these off to the side. Alright, so I'm going to lift this. Don't you hate it when that happens? Alright. And I'm going to get some clips. I'm going to clip onto that. It's a 470, so I'm going to go grab another 470 to bring it up to 1k, roughly. I'll get a 560. A 560 and a 470 is pretty well 1k. One sec. Probably just over a k. I'd kind of rather it be just over than just under for this experiment. So we've now got our 1.6k or whatever it is. Let's go power up, signal on, and clipping characteristics. Okay, so that's got an ugly again on the bottom. No, we don't want that at all. I hear oscillation. No, that's not happy. Alright. That could also just be from the lead length. Let me have a think. Alright, I've done some thinking and I still want to play around with this a little bit more, experimenting with different value resistor in here and the rail voltage, because there could be something I'm missing. I haven't really tried truly all the variables, So I want to look into this a little bit more, but as you can see, we're we're almost there without adding anything in the signal path. Look, signal comes out yellow wire, base of this transistor, comes out into this transistor. I haven't added anything in the signal path. So, you know, no Baker clamp, no tracking transistor. However, what I do want to go do some research on, remember I was saying, 100 ohm resistor won't really do anything, but, if you put 1K or bigger in there, you're going to start causing millimultiplication effect on the transistor, where you're going to get very varying capacitance on the transistor with varying current or voltage. I can't think, but you know what I'm trying to say. And we don't want that. So that's why you usually just put the collector straight to the rail, or maximum of 100 R there. Will the current source, because, current source acts as an amplifier essentially, or if you put it on top of an amplifier, it's going to add gain to it. You know what I'm trying to say. What my question is that going to millimultiply the beta enhanced transistor? So I need to go do some research on that, because I actually don't know the answer to that. And like I said, I wanted to experiment with these values a little bit more, but I think this is starting to come together. It's starting to look like I can make this work without putting band-aids on it. So I'm happy so far. I'm going to end the video here, because like I said, I've got some thinking and research to do, and I think this is already covered quite a bit. So thank you for watching, and I'll see you all very shortly. And for those wondering, yes, wires hasn't turned up yet, and yes, the bird is in my backyard still. Don't worry, it's alright with me. Thanks for watching.